Hello. So in this episode, we'll show a GAN first example. Okay, so let's go to the Google. Core Web. Okay, so here, we'll have a very simple task that the real data is a list of 1010. Okay, and we want to have a neural network, the generator that generates fake data that will generate something that looks like 1010. So first, let's get the real data. So generating the real sample, so 1010. Actually, to facilitate training, we make it a little bit noise. So it's like something close to 1, but not exactly 1 necessarily. Something close to 0, but not necessarily 0. And again, close to 1, close to 0. How do we do this? Let's say I have 0.2 noise. So it can be 0.8 through 1. And this can be between 0 and 0.2, 0.8 to 1, and 0 to 0.2. How do we do this? 1 minus dx, the dx is 0.2. So we create an array of this, right? And here, so it's what it does is that it has 0.8, 0, 0.80. And on top of that, we have a random noise of 0.2 multiplied by random normal. It's a random number between 0 and 1. So basically adds onto this 0.80, 0.80, it adds a noise that it can be between 0 and 0.2. So at the end of the day, it will generate something close to 1, close to 0, close to 1, close to 0, right? And we'll have 10 of them generated. So if you think you'll generate real sample, if you call it, and here the label is that if it's a true sample, which in this case it is, we give a label called Y, it's a 1, okay? Just for us to know that it's a true sample. Okay, and if we want to show that here, the 10 samples, so there are 10, and 0, 1, 0, 1, 0. So the darkest one, the brightest 0, isn't it? Okay, let's move on to generating fake data, n of them. So it's a random number, 4 random numbers out of n. Okay, so, and the label is 0 for fake data. So y equals 0, we put them in there. Okay, so it's a fake data. If you want to show it, it's like all over the place, bright and dark and bright and dark, isn't it? It's not like a regular pattern like here. The first digit is 1, the second digit is close to 0, and then 1, and then 0. So let's define a discriminator. So it's just a neural network. The dimension is 4, so it's 4 digits. It's a sequential network with 4 to 25 to 1. And then the 1 is, what does it output? It outputs, if it's true, it's 1. If it thinks it's a fake data, it outputs a 0 in there. So that's defining the discriminator. Let's train it. Let's see how it does. So we have 300 epochs and a batch of 100. And here's the model. The discriminator model comes in. So we train in half batch. We give a half batch of real data and half batch of fake data. So how we do it? So for each epoch, generate real samples. So we generate like a 1010 kind of sample, half batch, and get the data like the 10 by 4 digits. And the right real is 1. Isn't it? 1, 1, 1, 1, 1, 10 ones. And then update the model, train on batch. It's how we update and backpropagate and update the weights based on the real X and indicating that this is a real data. Y is 1. Okay, Y real is 1. And then give the fake samples, generate fake of a half batch, X fake and Y fake, and then train on batch the fake data and tell that it's fake data to discriminator. So the discriminator is trained. So it's a 0 here. Okay. And then evaluate the model of the real and fake and see how it does. So this is the train. So let's train that discriminator. So it will run for 300 times. So let's come back when it's done. Okay, it's done training. So let's see. If we give a real sample, see what it does. It predicts 1, meaning it's a real sample. The discriminator, if we generate fake sample and then give it to the predicted discriminator, then 0. Okay, so it does it. How about a generator? So let's have a generator. It's like a neural network. it takes latent dimension of 5. So it starts from 5 random numbers, goes through 15 nodes, and then n output. Output is actually 4, isn't it? It's supposed to generate 4 numbers in a sample. So let's develop the model and let's train the generator. The generator, it gets a latent point starting from, so these latent dimension 5. So it takes 5 random numbers as input. So we have a function that will generate 5 random numbers for n of the samples, n samples of them. And then using that, generate latent points. We have the generator predict the random image and generate it. And the class label is 0 because generator generates fake samples. So let's have it. But how to use it is basically generate fake sample, call that function of this generator model, latent dimension batch. And the number generated looks like this. It's not doing a good job because now it's not yet had an opportunity to be trained to fool the discriminator. We just trained the generated a generator, that's all, isn't it? So we need to train it, which is the GAN comes in. So how do we train a GAN? It takes 2 neural networks, generator and discriminator. And the discriminator weights are fixed. We do not update the discriminator weights. So it's the discriminator trainable, it's false. Okay? And then give a network, which is sequential network of first the generator and then add a discriminator. And together we call it GAN. So how do we train the GAN? As we talked about it, we first train the discriminator and then fix the discriminator and then train the generator to fool the discriminator. So with the real sample, get X real and Y real, train the discriminator on the real sample, give real data and tell that it's 1, it's real. Then generate fake samples, X fake, Y fake, and train the discriminator, okay? And evaluate, okay? So how do we do the train the generator and discriminator? So we get a half batch of real sample and fake sample, and then train the real and fake sample, and then have generate a random points which we are going to use the fake sample, isn't it? Okay. So the GAN is basically training the generator, okay? Okay, and then here is actually defining the discriminator and generator model and the GAN, and we train the generator, right? And it's running. Okay, it's done training. So let's see. So generate latent points and then have the generator predict after being trained by GAN. What it predicts is that, well, you can see here the picture. The darker ones are 1, the brighter ones are for each 10 samples 0. So it's 1, 0, 1, 0 pattern is successfully being predicted. Okay. So in a short, to summarize, define a neural network with certain key parameters like discriminator, generator, and GAN is declared. And then you need like helper functions to generate real sample, and then the latent points that is used to generate the fake data points. Okay. And then you basically train it. If you want, you can have a helper function to summarize performance like the losses and errors during the training process, and then have the training, which basically trains like half batch on real sample, half batch on fake sample, and then the GAN will basically be trained to fool the discriminator in a way that Y GAN is being put 1, not 0, although it's a fake data. Okay, right? And then you can declare and train it. So this is sort of simply how to have a GAN. Thank you for watching this episode.